Welcome to The Explainer. Today, we're diving into a pretty dense 27-page scientific paper that proposes a radical new theory of physics, one that could honestly change how we see everything. So, as the paper's author Anton Kleshev-Alavatynowicz would probably say, "Поехали, let's go."
So, the paper we're digging into today, it asks a really mind-bending question. One that gets right to the very heart of modern physics. It's asking, what if underneath the reality we all see and touch, there's a whole other layer? A kind of hidden blueprint with its own weird fractal geometry that's quietly guiding the entire universe.
Now, you might be wondering, why would anyone even come up with such a wild idea? Well, to get why, we first have to talk about a pretty famous problem in physics. There's this deep tension in how we see the world. It's like a crack that runs right through our most basic understanding of reality.
See, on one hand, you've got the completely bizarre, almost ghostly rules of the quantum world, where particles can be in many places at once, and things are all about probability. But then, on the other hand, there's the solid, predictable world that you and I live in. Things are here, not here and there. So how does that fuzzy, uncertain quantum world suddenly snap into the sharp, definite reality we experience? Honestly, bridging that gap is one of the single biggest headaches in all of science.
Okay, so to try and solve this exact problem, a 2025 paper from an independent researcher, Anton Kleshev-Alavatynowicz, comes along and proposes something pretty radical. It's a hypothesis that doesn't just try to, interpret all the weirdness. It tries to explain it by introducing a totally new physical thing. Right, the paper's called, and it's a mouthful, Field of Lumina, Warp-Resonated Symmetry, or thankfully FLWRS for short. And what it does is lay out this complete, testable, and deeply strange vision of reality. It says this hidden layer isn't just a cool idea. No, it's a real, tangible field that fills all of space-time.
So the whole theory is really built on three core ideas, or axioms. The first one is called lumina. The best way to think about it is like a hidden blueprint, a kind of substrate that exists just underneath reality itself. It's described as a fractal field, so it has these self-repeating patterns at different scales, and it only weakly or gently interacts with the quantum fields we're already familiar with.
Okay, axiom 2. This one's called logos. So if lumina is the blueprint itself, you can think of logos as the special, allowed patterns on that blueprint. They're like specific, pre-approved resonant frequencies. And when a physical system, say a particle or a big molecule, just happens to vibrate in a way that matches one of these logos patterns, well, that's when things get interesting.
And that interesting something brings us to the third and final axiom, luminescence. This is the engine of the whole thing. It's the active mechanism that literally tunes reality. So when a system hits one of those special logos resonances, luminescence kicks in, grabs that quantum state, and makes it way more stable. This is the process that this theory claims guides that fuzzy quantum world to snap into one specific, stable reality.
But look, the author isn't just, sitting in an armchair philosophizing. This quote from the paper's summary makes it absolutely crystal clear. It says, and I'm quoting here, "This version is intentionally concrete and engineering-oriented." So it's basically presented like an engineering manual designed for people to take into a lab and test. The author is literally daring the scientific community to try and prove it wrong.
And this is super important. The theory isn't just words. It translates all these concepts into hard mathematics. Now, we're not going to break down this entire equation here, don't worry. But you don't need to be a physicist to get the main point. This thing, the fundamental equation of dynamics, is the engine at the heart of the whole model. It's what turns the ideas, lumina, logos, luminescence, from words into a machine that can actually make predictions.
And that brings us to what's probably the most important part of any new scientific idea, right? You have to be able to test it. If you can't, it's not really science. It's just a nice story. And FLWRS, well, it comes with a whole menu of ways to put it to the test.
And what's amazing is how diverse these proposed tests are. We're talking about looking for evidence in the ticking of hyper-precise atomic clocks, in the weird quantum behavior of giant molecules, all the way to the synchronized firing of neurons in our own brains, and even in the light that's traveled across the cosmos from distant stars. It's looking everywhere. Okay, but one of the most fascinating and, you have to admit, pretty speculative proposals is the one that involves the human brain. The idea here is to treat the brain as this unbelievably complex biological system. The thinking goes, if these lumina resonances are real, their effects might, just might, be detectable in the way billions of our neurons fire together.
And here's the crucial point. This isn't just a vague idea. The theory makes a specific numerical prediction. The paper says, stimulate the brain with a 40 Hz current and measure what happens with an EEG. It predicts you'll see a specific jump in brainwave synchrony, a value of around 0.15. Now that would be way beyond what you'd expect from standard physics. It's a clear, testable line in the sand.
So this brings us to the really big question, doesn't it? You've got the theory. You've got the predictions. You even have the designs for the experiments. So what if it's true? What does it all mean if this thing is actually right?
Okay, but before we all get too carried away, the paper itself really hammers home the most important principle of good science, and that's falsifiability. A theory is only as good as its ability to be proven wrong. And to his credit, the author has done the hard work of laying out exactly what failure would look like. In fact, if you look at this table from the paper, the author explicitly states what a failed experiment would look like. For example, if scientists run those atomic clock experiments and find absolutely no frequency shift, well, that would seriously damage, if not outright kill, the theory. Every single one of these proposed experiments has a clear null result, a failure condition that would help falsify the hypothesis.
So where does that leave us? Well, we're at a crossroads, really. This theory is either a fascinating but ultimately wrong idea, a beautiful dead end, or it's a doorway to a completely new way of understanding physics, a Nobel Prize-winning revelation about the fundamental structure of our universe. There really isn't much of an in-between here. The big takeaway here is that the hypothesis is officially on the table. It's out there, and it comes complete with the mathematical recipes and the experimental instructions. The author has thrown down the gauntlet, daring the scientific community to actually test it. So the only question left is, who's going to be the first to start cooking?